Welcome to this explainer, where we are going to completely transform how you tackle the Cambridge Computer Science exams. We are looking specifically at syllabuses 9618, 0417, 0478, 0983, 0984, and 2210. I want you to think of a massive, complex past paper question like a giant block of unrefined marble. Now, the average student walks into that exam hall, panics, and just tries to smash that marble with a hammer, hoping something good comes out. But top-tier candidates? The ones getting the A stars, they are sculptors. They don't smash. They know exactly where to strike. They use precise, targeted frameworks to chip away all the irrelevant details and reveal a high-scoring masterpiece hidden right there within the scenario. Today, we are bringing that sculptor mindset to one of the most notoriously misunderstood topics across all of these syllabuses, and that is database relationships.
Okay, let's take a quick look at our blueprint for today. We are going to kick things off with the challenge. Clarify the core concepts, lay out a step-by-step procedural framework, dive deep into critical analysis, and wrap up with the absolute most important top examiner warnings.
We have to start with a pretty harsh reality pulled straight from the principal examiner reports. This quote really sets the stakes for why mastering one-to-one, one-to-many, and many-to-many relationships is absolutely critical. A senior examiner recently pointed out that most students are literally throwing away easy marks on this topic. And honestly, it is so frustrating to see because the underlying theory is not usually what trips people up. It is the application. See, most students can easily memorize what an entity relationship diagram looks like in a textbook, but the second they sit in that exam hall and are asked to justify a specific relationship type in the context of, say, a busy hospital database or a university booking system, they just freeze up. They give generic answers and they lose easy marks. But by the time we are done today, you are going to have a foolproof system so you never make that mistake again.
To really understand the trap, let us look at two classic student profiles. I guarantee you know someone like Alex or Sam, or maybe you've even been them. Let's imagine a real-world past paper question that says, evaluate the use of a many-to-many relationship in a proposed library system. Now, Alex is the over-preparer. Alex sees the word database and just starts writing a massive, unstructured paragraph explaining absolutely everything there is to know about databases. We are talking primary keys, foreign keys, the history of normalization, you name it. It is a complete overload of raw computer science facts. But guess what? There is zero analysis of the actual library system. Alex gets 0 marks for application because they didn't answer the question being asked. Then we have Sam. Sam is watching the clock. Sam sees the phrase many-to-many, immediately panics about the time limit, and rushes out a quick sentence about junction tables. But Sam completely ignored the specific command word at the start of the prompt, which was evaluate. Sam missed the fact that the word evaluate actually requires you to look at both the advantages and the potential limitations of the system. Both Alex and Sam are working hard, but they are both failing to maximize their mark potential.
So how do we fix this? Let's move into our first major section, core concepts, and establish the theoretical architecture you actually need for top-tier marks, because you simply cannot apply a concept that you cannot clearly define.
Let's ground ourselves in the exact definitions and causal links that Cambridge examiners demand to see before they give out any analysis marks. First up, the one-to-one relationship. These are rare, but they are critical. Think of a system where one unique user has exactly one highly secure login profile. Next is the one-to-many relationship, which is literally the backbone of relational databases. If you think about an e-commerce store, one single customer can place many different orders over time, but each of those individual orders belongs to exactly one customer. And then we have the notorious many-to-many relationship. This is the big one. Imagine a university. A student takes many different classes, and a single class contains many different students. Now, conceptually, a direct many-to-many relationship makes perfect sense, but practically, it is impossible to implement directly into a standard relational database without causing massive data redundancy and severe update anomalies. You absolutely have to resolve it. And proving to the examiner that you understand exactly how and why to resolve that interaction is the difference between a passing grade and an A star.
Another huge secret from the principal examiner reports is that candidates who make cross-topic connections achieve significantly higher marks. Examiners go crazy for this. They want to see you link database relationships to programming concepts. For instance, explaining how arrays or linked lists might be utilized to handle this relational data in active memory. Showing that you understand how these concepts interact in the broader computer science landscape is a game changer. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's transition into the procedural framework. Knowing the textbook definitions is only step one. Now we need a reliable, step-by-step strategy to actually extract those marks from the examiner.
If you follow these 5 sequential steps every single time, you will systematically build an answer that guarantees you pick up every available method mark. And remember, in Cambridge mark schemes, method marks are your safety net. You get points for the correct process, even if your final conclusion goes slightly off track. Step 1. Deconstruct the question. Grab your pen and physically highlight the command word. Is it describe, explain, or evaluate? That dictates your entire approach. Step 2. Extract the data. Find the specific entities hidden in the scenario text, like doctors and patients, and circle them. Step 3. Select your analytical framework. Step 4. Execute with precise notation. If they ask for an entity relationship diagram, you better be using the exact, correct crow's foot notation, no messy sketching. And Step 5. Present with correct terminology. Do not ever write something vague like, the data connects to the other data. You need to say, the foreign key in the many-side entity links directly to the primary key in the one-side entity.
To make that presentation flawless, you need to integrate the Peel framework. This ensures that your algorithmic thinking perfectly aligns with what the assessment objectives are actually grading. This is your ultimate structure for any written response. P stands for point. Simply state the relationship clearly right out of the gate. E is for evidence. Pull the specific entity names straight from the scenario text provided in the exam. E is for explanation. Detail the technical mechanics. If you identified a many-to-many relationship, this is where you explain that a junction table must be created utilizing a composite primary key. And L is for link. Connect it all back to the context. Why does this specific library system benefit from this structure? Because it prevents a single book's title from being redundantly duplicated thousands of times across the database.
Let's look at this transformation in action. The flawed answer on the left is what most students write. It just vaguely states a fact. But the masterpiece answer on the right uses the Peel framework perfectly. It states the relationship, applies it directly to students and classes, explains the deep technical necessity of a junction table to resolve redundancy, and beautifully links it to space complexity. That is exactly what an A-star answer looks like. Stop scrolling. Subscribe to our YouTube channel ACE Exams at ACEXams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @ACEXams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's step it up a notch and enter critical analysis and evaluation. Elevating your answer from just good to truly exceptional requires you to evaluate data structures critically. Let's see how the top 1% do it.
I want you to treat this like a data scan challenge. Look closely at how we analyze trade-offs here. In a high-level paper, especially for Syllabus 9618, you are not just building a database, you have to evaluate its efficiency. Look at the focus areas. When you introduce a junction table to fix a many-to-many relationship, you are massively improving space complexity because you are removing redundant data and saving memory. But there is a trade-off. You might actually be negatively impacting time complexity. Why? Because querying that data now requires an SQL join operation across 3 separate tables instead of just 2, which naturally takes more execution time. Discussing that exact push and pull, that trade-off, is the absolute pinnacle of critical analysis.
When you perform this kind of comparative analysis, you have to identify similarities, differences, and support everything with hard evidence. Let's do a quick find the flaw exercise. Imagine you are grading a paper, and the student wrote, "The database is good because it connects entities fast." What is the massive flaw there? It completely fails every single evaluative thinking requirement we just talked about. It ignores trade-offs, it acknowledges absolutely zero limitations, and it provides zero context from the prompt. Now listen to a top-tier candidate. While the normalized one-to-many structure prevents updated anomalies, a limitation is the increased processing time for complex relational queries. However, given the scenario prioritizes data integrity over millisecond query speeds, this structure is fully justified. Do you hear the difference? That is how you secure the bag.
And when you are under pressure, this deconstruct, solve, evaluate cycle is your ultimate speed writing blueprint. When you only have a few minutes left on the clock, you don't have time to stare blankly. You quickly identify the given entities, you break the relationship down. If a doctor sees many patients and a patient sees many doctors, that's step 1. Step 2, you solve it systematically by introducing an appointments junction table. Step 3, you check reasonableness. Does it logically make sense that a single appointment connects exactly one doctor to one patient? Yes, it does. Step 4, you write down your justified recommendation. It keeps you moving fast and accurately.
We are entering the final phase now. It is time to look directly through the examiner's lens and highlight the absolute worst traps that destroy otherwise perfect answers.
We have come through years of principal examiner reports to find the top 3 mistakes. Students who avoid these see massive score jumps. Mistake number 1 is vagueness, writing "they are linked" instead of "they are linked via a foreign key constraint." You have to use the technical vocabulary. Mistake number 2 is forgetting edge cases. Think about the extremes. What happens if a brand new class is created but has 0 students enrolled yet? Does your database allow for that, or will the whole system crash because of a null value? And mistake number 3, this is the deadliest sin of all: generic answers. If the exam prompt is about a local veterinary clinic and you panic and write down a memorized textbook answer about students and teachers, you will score a 0 for application. You have to use their scenario.
To guarantee you never fall into that generic answer trap, I want you to memorize this exact hack. CEB: context, edge cases, boundaries. Before you drop your pen and move to the next question, look at your paragraph and ask yourself, did I explicitly use the context? Did I consider an edge case? Did I check the boundaries? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.
So, I leave you with this. How will you systematically chip away all those irrelevant details to reveal the masterpiece in your very next past paper? Take this framework, apply it immediately to a practice question, and completely transform the way you approach Cambridge computer science. The marks are already right there in the stone. You just need to sculpt them out with precision, logic, and context. Keep practicing, keep evaluating those trade-offs, and go absolutely master those exams.